Good morning, all. Dear students, you are all welcome to a new session of the chapter sets. Today, we are going to discuss one of the important concepts of the chapter sets, that is, operations on sets. First of all, we have to understand what do we mean by operation. For that, consider the numbers as example 8 and 9. We can do using these two numbers 8 and 3 some operations like addition, subtraction, multiplication, division, etc. These four are called the basic operations on numbers. In a similar way, when we consider two sets A and B, we can perform some operations on these sets A and B to get new set that we are going to discuss today. Consider the sets. A is equal to set 2, 4, 5, 7 and B is equal to set 5, 7, 8, 9. I am going to operate these two sets and write a new set like this. Can you say what I have done to get this set? Yes, I have written all the elements which are either in A or in B or in both. It means that I take the union of A and B. This is called union of A and B, and the symbol to represent union of A and B is A union B. Okay, then by A union B, we mean that set of all elements which are either in A or in B or in both. Consider another example. C is equal to set A, E, I, O, U and D is equal to set A, B, C, D. Then what will be C union D? The set of all elements which are either in C or in D or in both. For that, first we have to write all the elements in C, A, E, I, O, U. Then the elements in D, A, B, C, D. But no need to write A twice. Then what will be C union G, A, E, I, O, U, B, C, D. The symbol is like this, C union G. Clear? I think it is what do we mean by union is clear to you. Then take it down in your notebook. Write the subheading union of sets. The union of two sets A and B is a set of all elements which are either in A or in B or in both and is denoted by A union B. Now we are going to write the set builder form of A union B. A union B is basically a set. It contains some elements. Let us represent it by X. Then we want to write the common characteristic property possessed by all the elements of A union B. What is that? The elements are in A, X are in A, or the elements are in B. This is the set builder form to represent A union B. How can we read this? A union B equal to the set of all X such that X belongs to A or X belongs to B. The word or is very important. The word or is very important. Therefore, A union B can also be read as A or B. Then A union B equal to set of X such that X belongs to A or X belongs to B. Now write some examples. First one, consider these sets S equals set 2, 4, 5, 7 and B equals set 5, 7, 8, 9. Then what is A union B? That is the elements which are either in A or in B or in both. List every element that present in A or B. Clear? Now another example, C and D. Then what is C union D? that is A, E, I, O, U, B, C, D. Okay. Now, third example is this one. Consider the set S equal to set of all x such that x is a natural number and 1 less than x less than or equal 6 and b is equal to set of all x such that x is a natural number and 6 less than x less than 10. Then what is A union B? What are the elements in A? In A, the elements are natural numbers from 1 to 6, excluding 1 and including 6. Therefore, the elements are 2, 3, 4, 5, 6. And in B, the elements are 7, 8 and 9. Then what is A union B? A union B is equal to 2, 3, 4, 5, 6, 7, 8, 9. Or in set builder form we can write set of all x such that x belongs to n and 1 less than x less than 10. It means that all natural numbers in between 1 and 10. And the last example is this one. Consider the sets S equals set to 5, 8 and B is equal to 5. Then what is A union B? Here A contains 3 elements 2, 5, 8 and B contains 0 element. B contains 0 element. Then what is A union B? A union B is the set of all elements which are either in A or in B or in both. Since B contains 0 element, A union B is equal to A itself. Very simple, very clear. Okay. Now, we are going to learn Venn diagram of A union B. How can we draw the Venn diagram of A union B? For that, first draw the set A using a circle and another set B using another circle. When we draw a Venn diagram, we must draw the universal set using a rectangle. The symbol for universal set is U, as you know. Now, we want to shade the portion A union B. In A union B, the elements are the set of all elements in A. For the same reason, we first going to shade the portion A in total. Then shade the portion B in total, because A union B means set of all elements which are either in A or in B or in both. So, shade the portion B wholly. The shaded portion represents A union B. Clear? This is the Venn diagram to represent A union B. One thing is important, that it is not always, it is not compulsory to draw two sets A and B like this. Sometimes the two sets may be like this also. In that situation, what is A union B? At that time, A union B is set of all elements in A, so shade the portion A completely, then shade the portion B completely. This represents A union B when A and B are not intersecting. Okay, sometimes A and B may like this also. In this case, A is a subset of B. A is a subset of B. Then what will be A union B? Shade the portion A at first, then shade the portion B. Here A union B is nothing but B itself. Do you know what is the reason? Yes, clear. Here A is a subset of B. When A is a subset of B, A union B equal to what? B itself. Then my question is, if B is a subset of A, then what will be A union B? That is A itself. The superset is the union always. So draw these figures in your notebook beautifully, and after that write these notes. First note is this one. If A is a subset of B, then A union B equal to B. If A is a subset of B, then what will be A union B? That is B. In a similar way, if B is a subset of A, then what will be A union B? A. The superset is always the union. Okay. Now third note is, what is A union phi? A union phi equal to A. That is very simple note. Here phi is a subset of A, therefore union is the superset A. Clear? Now we are going to learn some properties of union. Listen. Let S equal set to 5, 8 and B equal set to 3, 4, 5. Then what is A union B? That is very simple. That is 2, 3, 4, 5, 8. Then what will be B union A? Is there any difference? No. B union A is also the set of all elements which are either in B or in A or in both. Then it become 3, 2, 4, 5, 8. Since in roster form or in set, there is no importance to the order in which the elements are listed. Therefore, we can write in any order. It means that A union B equal to B union A. That is one of the very important properties of union. Let us write it first. A union B equal to B union A. This property is known as commutative law or commutative property. Then what is the first property of union? A union B equal to B union A. The property, the law is called commutative law. Commutative law states that there is no importance to order in which the union is taken. Okay. Now the second property. To say the second property, we want to take three sets A, B and C. Then what is A union B? Union C. We know that A union B is equal to set 2, 3, 4, 5, 8. Then take union of A union B with C. C is 0, 1. Then what is the answer? 0, 2, 0, 1, 2, 3, 4, 5, 8. Okay. Then when we take A union B union C in this order like this, A union B union C, then also the answer is the same, 0, 1, 2, 3, 4, 5, 8. It means that A union B union C is equal to A union B union C for any three sets A, B, C. This property is known as associative law or associative property. Then what is associative law or associative property of union? Say with me, A union B union C equal to A union B union C. Okay, A union B, then take a pause. A union B union C equal to A union B union C. Clear? Now third property is this one. For example, 3 plus. To understand what is the third property, let us take an example for numbers. Okay, 3 plus something is equal to 3. Which is that number? 3 plus what equal to 3? It is clear, that is 0. It is not a property of 3 alone, but it is a property of all the real numbers. Okay, 5 plus 0 equal to 5, 7 plus 0 equal to 7, minus 1 plus 0 equal to minus 1. It is common to every real numbers. Okay, this property is known as identity law. The same fact hold for set also. See, A union some set equal to A, which is that A union A set equal to A, then which is that this set? That set is very simple, empty set. A union phi equal to A. This phi exists for every set A. Therefore, we can say that union possesses identity law and the identity is the empty set. That is the third property. A union phi equal to A. This property is known as identity law and phi is called the identity of union, just like as 0 is called identity for addition. Okay. And the fourth law is A union A. What is A union A? You can say very easily that A union A is equal to A itself. This law has a beautiful name, that is idempotent law. Idempotent law. Okay? And the fifth law, fifth property is A union U. A is a subset of U. I mentioned before that when we take the union of two sets, one is a subset of another set, then the union is the superset. Therefore, here the answer is U. This law is called the law of U. These are the 5 properties of union. So far we have discussed all about the operation union. Now we are going to learn a new operation. For that, see the example A and B. I am going to write a new set using these two sets A and B. Okay, can you say which operation I had done? Which thing I had done to write the new set? Very simple. I have written the elements that are common to both A and B. Here 5, 7 are common, are in A and in B also. It means that it is common to both A and B. To write this set of all elements which are common to two sets is called intersection of A and B. The symbol for intersection is like this: A intersection B, the reverse order of union. A intersection B. Then what do we mean by A intersection B? The set of all elements which are common to both A and B. Take another example, these two sets. Then what is C intersection D? C. Which element is common to both C and D? That is A. A is the element common to both C and D. Therefore, C intersection D is set A. The symbol is like this. Okay. Now, write this fact in your notebook beautifully. That is our second operation, intersection of sets. Write the intersection of two sets A and B is the set of all elements which are common to both A and B and is denoted by A intersection B. Now we are going to write the set builder form. A intersection B is a set that contains number of elements. That elements, let us represent it by X. And what is the property of this X? This X is in A, not only in A but also in B. Therefore, we write and X in B. This is a set builder form of A intersection B. The word and is very important. When we replace this and by or, union intersection become union. When I write or here, this intersection become union. Therefore, and is also intersection is also called and. We can read this A intersection B as A and B also, because the reason is this word. Okay, A or B, A union B, A intersection B, A and B. Now write some examples to represent to explain what is the meaning of intersection. Consider these two sets. Then what is the intersection B? Very simple, the elements common to both A and B, that is 5, 7. Another example is this one, these two sets. Then what is C intersection D? Very simple, that is set E. Set E is the common to both A and B. Third example is this one. C. A is equal set of all x such that x is a natural number and the natural number is greater than 1 and less than or equal 7. And another set B is natural numbers greater than 4 and less than 10. Which are the elements common to both A and B? Common to both A and B. There is no 4 here. There is no 4 here. Therefore, 5 is here. Here also there is 5. Then starting from 5, 5, 6, 7 are here. That numbers are here also. Therefore, A intersection B is equal to A intersection B equals set 5, 6, 7. Clear? Elements which are common to both A and B. Or we can write like this in set builder form. And the last example is consider this set A is equal set to 5, 8 and B is equal set to 5. Then what is their intersection? Since B has no element, intersection also contain no element, because B has no element. We want to write all the elements which are both present in A and B. Here there is no element, therefore A intersection B contain 0 elements. Okay. Now we are going to learn the Venn diagram of A intersection B. Draw two sets A and B, then universal set U by a rectangle. Then we want to shade the portion which is common to both A and B. Which portion is common to both A and B? Is this portion? No, this is not portion of A or B. What about this? This is a portion of A but not in B. What about this one? This is a portion of B but not in A. Which portion is common to both A and B? Okay, very simple, this portion. Therefore, this portion represents A intersection B. The set of all elements common to both A and B. Sometimes the two sets A and B may like this, do not intersect. Then what portion represents A intersection B? Here there is no portion common to A and B. Therefore, we cannot shade the portion A intersection B. Here there is no green shaded region. It means that there is no intersection in common. Sometimes two sets may be like this, A subset of B. Then which is common to both A and B? Very simple, A. A is the common region. A is in A is in B. Okay, A is the common region to both A and B. Therefore, A intersection B can be shaded like this. Okay, from this we can write a node, which is that node when A subset of B, A intersection B is equal to A. When A subset of B, A intersection B equal A. In a similar way, we can say that when A, B subset of A intersection B equal to B. What is A intersection empty set? That is simple, empty set itself, because phi is a subset of A. When we take the intersection of two sets, one of them is a subset of another one. The subset is the intersection. Okay, superset is the union and subset is the intersection. Clear? Now we are going to learn some properties of intersection. First property, as just we mentioned before in the case of union, A and B are two sets, and I am going to write what is the intersection B, that is set 5. Then what is B intersection A? That is again set 5. It means that A intersection B and B intersection A are same. What is the name of that property? That is commutative law. It means that when we take the intersection of two sets, there is no importance to the order in which we are taking. Order has no importance. That is the relevance of commutative law. Okay. Now the second property to say about second property, we want to write three sets. C is the third set. Then what is A intersection B? Intersection C. A intersection B, there is a pause. After say intersection C. A intersection B, intersection C equal to set 5, 6 intersection set 1, 6. It is very simple, set 6. Then what is the intersection? B intersection C, it is again set 6. What is the meaning? These two intersections are same. We can take the intersection of three sets in these two ways. Both are same. That is the second property. This property is called the associative law. A intersection B intersection C equal to A intersection B intersection C. And the third property is A intersection phi. What is A intersection phi? You know the answer is phi. This law is called law of phi. And fourth property, A intersection A. What is A intersection A? Very simple, that is A. The property is called idempotent property, idempotent law. And the fifth one is A intersection U. A is a subset of U. I mentioned earlier that when we take this intersection of two sets, one of them is a subset of another one, then the answer is the subset. Here the subset is A, therefore answer is A. This property is called law of U. And the sixth property, which is not mentioned before, that is only for intersection. A intersection B union C is equal to A intersection B union A intersection C. Here the operation intersection distribute over union. Intersection distribute over union. A intersection B union A intersection C. Okay. In another way we can say that A union B intersection C is equal to A union B intersection A union C. A union B intersection A union C. Just like as A into B plus C equal to A B plus AC. This property is called distributive law. To say about distributive law, it is essential that there are two operations are needed. Okay, now the 6 properties of intersection is over. Now we are going to say one more thing relating to intersection. See, A and B are two sets. What is the intersection of A and B? Is there any element common to both A and B? No, there is no element common to both A and B. It means that A intersection B is empty set or phi. Okay, when the intersection of two sets are empty, it means that they are not joined. Therefore, these two sets are called disjoint sets. Very important. Disjoint set. Then when we say that two sets are disjoint, yes, two sets are said to be disjoint if their intersection is equal to empty set. One of the very important fact on set. Therefore, write in your notebook beautifully. Disjoint sets. Two sets A and B are said to be disjoint if A intersection B equal to phi. Okay, some example. First one, these two sets. Are the set disjoint? Yes, there is no common numbers to both A and B. Therefore, the two sets are disjoint. A intersection B equal to phi. What about these two sets? Are they disjoint? No, because A intersection B is not equal to phi, it is equal to set E. Therefore, the two sets are not disjoint. Then, when we say that two sets are disjoint, their intersection is empty. Then, Venn diagram of disjoint set. How can we draw the Venn diagram of disjoint set? Okay. First, draw the set A. Then, how do we draw the set B? Like this. No connection with A. This is the Venn diagram of disjoint sets. Clear? Today's class is over. Today we have discussed the very two important properties of the sets. The coming session we will learn the third operation. So before attending the coming class, the next class, all of you have a thorough idea about the two operations we have learned today. Thank you for watching. Have a nice day. Goodbye.